Lesson 20, we're starting percents chapter, and you're going to have a list of all kinds of different ways that you can solve proportions, which is actually percents also, but all depending on the kind of question and what it's asking. So we're going to start with method number 1. And when we look at method number 1, it's talking about just percent of a number. I know it's really dark here, but percent of as a number is just, you have two ways to do it. You can either set up a proportion, which you are definitely used to from the previous chapter. Now this makes it really easy because this is always over 100. No matter what they're giving you, let's say it's 72%. And they are going to be setting up the X up here whenever it's a percent of a number. And then let's say you have 25 here. And you would definitely go ahead, right, and cross, multiply, and divide to get your missing X here, your question mark. That you're used to because of proportions. Now, when they are asking you for a percent of a number, you can also do this very easily on your calculator by doing it just like a one-step type of thing. You don't have to set up like we did up here, but you can just say, so we're going to use the same numbers. Maybe they're asking you what is 72% of 25. That's exactly what is a percent of a number. You would easily type into your calculator 25 times 72% equal sign to get your answer. Now, previous knowledge, you could also change that percent to decimal 72 to actually do a very easy, straightforward calculation. So if I show you by going to my calculator and I do have a percent button that you can see. So I would have 25 times 72, and I would press on my percent button. See how it changes it to decimal 72? Some of your calculators might do that. Equal sign. I get an 18 as an answer here. So 18 out of 25 would give you 72%. You can actually test that. So let's pretend that that was a mark on a test that you got 18 out of 25, right? So we can just test that theory. Is 18 divided by 25 would give you 70.72. You would then say multiply, and it gives you 100. It gives you 72. Okay, so I'd like you guys to go forward and start practice. So all these examples are just plain and simple, a percent of a number. So we can easily just, so as you're copying these notes, if you're using the videos to do your notes, definitely take a look at your calculator. Look for the percent button on your calculator. You might have to second function, shift. Those might be like, it might be green. Those buttons might be orange. I have actually even seen those buttons as red. So really depending on your calculator, you would have different shift buttons and different colors on the plastic part of your calculator. It's like doing the caps or shift button on a computer, same idea as your calculator. So if you have difficulty with that, please ask me where that percent button is. If you really don't like where your percent button is on your calculator because you have to shift and function and all that stuff, you can easily right away get in the habit of just changing that automatically to a decimal, let's say decimal 4, which really is decimal 40, which is really just decimal 4. I'm big on the less amount of stuff that you have to type in, the better it is. So the first one, I will use that 40% button so that I can show you both ways, okay? So here, too bad you can't see the display on my calculator, but 180 times 40, and I'm going to get my percent button there. It's going to change it to a 0.4, and I'm going to click an equal sign. So for my calculator, I do have to click on the equal sign. For some of your calculators, you might not have to. So it's really a matter of testing your calculator, how it works. If I change it up a little bit and just set it up as a proportion, so 2 always over 100, 123 is your 100% of the bag, let's say, of whatever the items are. And here you are going to set up a cross, multiply, and divide. So that you would say 2 times 123 equal divided by 100, because that's the number you haven't touched. So that gives you 2.46, which makes sense because it's only a little 2% of 100 there. 75% of 100 is almost a trick question. It's already based on 100, so you would just have 75. Again, here I would take this number times 15%. This time let's change that to a decimal 15. So I'm trying to give you all the different options. Whoops, it would be good if I remember the numbers. So 50.55. So we'll clear 50.55 times decimal 15 automatically. And that would give you 7.58 as an answer. Okay, so once again, both options. Please be careful. A little trick question that if I'm looking at 2% and I'm changing that to a decimal, you're dividing this by 100. So you're moving over your decimal 2 decimal spaces. Sorry, that should be a decimal 0.2. And if it's 20% and you're moving over that decimal twice, that gives you a decimal 2. This is a common mistake. It's very different. This is 2%, this is 20%. Just keep that in mind if you're changing your numbers to decimals. The next one here, okay, more of a paragraph form. So this one here, I'll just change the color here so you can follow. Okay, Joe received 75% on his math test. Okay, we know that 75% is based out of 100, always, the percent. What did he get out of 25 marks? Okay, I can right away do this and say it's not based on 100, but it's based on 25. Cross, multiply, and divide. I think this one here gives you like 18. So 25 times 75%. Yeah, it gives you 18.75. So that's what you got on a test. I would definitely give you 19 out of 25 for your mark there, okay? Same thing for here. Take this number. It is saying 80% of the Molson Center were sold. 80% of the seats of the Molson. The total seats is 60,000. I don't think that's accurate. I think that's more than Olympic Stadium that has 60,000 seats. How many seats were sold? So I want to know what 80% of the actual seats were sold. So I can just multiply that up. I believe it's 48,000. Let me just double check my math there. 60, 1, 2, 3 times 80%. Yeah, it's 48,000 seats right there. That is all just simple, different ways they would present to you that you just want to know how much percent of a certain number is. That's your first method. Second method that we're going to look at in this lesson here is calculating the value corresponding to 100%. Okay, so percent increase. We also look at percent increase and decrease, and we also look at interest rate. So calculating the value corresponds. So this now, if it's not just simply a percent of a number, you can no longer just multiply the number. So you can't just say here 200 times 25%. Read the question. Are they asking to take 25% of the 200? Or in this question, it actually tells you that 25% is 200 seats. So this is where I would always say, always do a proportion to fill it in, okay? So here, when it talks about corresponding to 100%, that means here's my 100%. Let's pretend we're talking about 27%. They want to know this. Your X is on the bottom. You want to know the real value. And let's say, I don't know, I have 197. That represents 27%. Then you would cross multiply and divide. So this first example, right? So 25% of the school's population attended the dance. Okay, 25%. Right away, I can say in my mind, okay, 25%. If 200 people were at the dance, so right there, it's telling you they were at the dance. 200 represents 25%. So that total changes. I just have to make sure I line it up properly, like you did in proportions. Super easy. So if 25% is 200, then it goes together on top. And you're looking for, in this case, the total population. You're looking for the 100% of the population. Again, cross multiply and divide, and that would give you 800. This is an easy one to do. You could definitely do cross multiply and divide if you want, or you can definitely do scale factor, right? So I could say, oh, that's easily times 8 times 8. That gives me 800 for the total population there, okay? Next question would be 50. 50 is 25% of what number? So they're telling you that 50 is 25%. Super easy. 25% on 100. And that 50 is not the total. It's actually representing just the little 25% that you have here. So it goes on top. They want to know what that final answer. Now this is a super easy one, times 2, cross multiply and divide. So here your answer is 200. So notice the previous page, when you did your x's, your x was on top, not on the bottom. So a little bit different there, okay? If you're never sure, set up your proportion and you'll always get it right. The next question here, type of percent solving, is percent increase and decrease. That just means exactly what it sounds like. If I'm saving something, I could say, oh, 20% decrease means basically 20% savings. So I want to know how much money is increasing or decreasing. And it's possible that you also have an increase. You can have something that's increasing to 200% of its value, the original value being 100, so it's increased quite a bit. But we don't often see that, but it does exist. So for example, here's your little formula, and we're just going to use that to fill in, because the key word is here. It's saying calculate the percent increase or decrease, increase, and they're talking about discount here. So if I know right away it's talking and asking you this, I would refer to that formula. Now this formula is talking about, let's fill in the numbers. So the x is looking for percent, which makes sense. Over 100, halfway done. Your job is halfway done. Then I have to make sure that I know what to fill in here and what to fill in here and in the right spot. Now, the one on the bottom is your original. So the 205 or the 175? The 205 is your original before any rebate or anything like that. So 205 is your original cost. Now be careful here. I want the difference. I do want the difference. How much money did it decrease by? So I need to subtract 205 minus 175. So I need to have the difference between those. Even if it's increased or decreased, I want to know the difference between the two numbers. So the old number and the new number. So here I have a savings of 30. So right away there, obviously scale factor is not so easy from going from 100 to 205. So in my mind, I would definitely do cross multiply and divide. So 100 times 30 divided by 205. So your final answer here, if I can keep those numbers in my head, 30 times 100 divided by 205. I get 14.63. And what does that represent? 14.63. You are solving for percent here, so make sure that you're putting your percent. Most of the time when it's percent, it does come up to a whole number. Another word for sure that we would be used to and seeing would be interest rate. Now, we're going to do a lot of practice on interest rate, and we're going to talk about in class what it actually means, right? Interest could be money that money you owe. So if you borrow a car for so much money, for $25,000, well, and they charge you 1.27% interest over so many years, well, your car is no longer $25,000. It's $25,000 plus that definitely comes out to a couple of $1,000s of interest because you're borrowing that money. Sometimes interest is also given to you. So if you're investing your money, so if you put $5,000 away and they give you 10% interest for the year, you've just made $500 on that 5,000. So after a year, you would no longer have only 5,000 in the bank. You would have 5,000 plus the original money that you had. So in your bank account, you would have now this kind of money. So it could work either way, okay, for interest. So in this example, and it's just percent of a number, so calculate the value of interest you would make if you invested $2,500 for 1 year. Now, interest is always based on 1 year. If you take it out sooner, then they take a part of that away also proportionally, okay? So interest, if you're charged or you're leaving it somewhere, it is always based on a year. So here I would say 2,500 times, and if you're putting that kind of money away for this kind of interest rate, that's a very, very good interest rate. So I would say 2,500 times 12.5% equal sign. Oh, I'm going to make it $312.50 extra after 1 year. So that would be proportionally. Obviously, if I only do it for 6 months, I would cut that in half. So here, answer the question. They're saying calculate the value of interest you would make if invested. Here they're asking you how much money's in the bank just from interest would be this. If they asked you what was the total amount of money in both your interest and your principal amount. So this is the principal that you put down, plus this would be your answer. But for this question, this is your answer because they're just asking you what's your interest you're going to make. It's not asking you what is left in the bank account in total.